Hello, good afternoon. My name is Tristan Sampson, and our group's presentation today will be on nanotechnology's breakthrough in the biomedical field. I'm currently a mechanical engineering major here at UCF, and nanotechnology does have many applications throughout many engineering, but specifically for mechanical engineering, the design and construction of miniaturized robots and miniaturized processes have been huge in developing other things, and even things that we use every day, such as toothpaste and in concrete. Using nanotechnology and using it to its potential can even help improve energy efficiency, enhancing surface properties, and even developing self-healing materials. Obviously, right now, nowadays, nanotechnology is not up to the current standards that we hope to be someday, such as in pop culture and what it's fantasized as. But hopefully, one day, with our breakthroughs, we will get there. Our main claim: the use of nanotechnology started around 40 years ago, and since then, there has been massive leaps within the uses of it, such as I said, mentioned before, nowadays with toothpaste and concrete being used all over the world. The word nano is often referred to things around the atomic level, such as 1 nanometer, and that is equivalent to 1 billionth of a meter, which is, as you can imagine, very small. To put that into perspective, atoms have an average radius of about 0.1 nanometers, obviously not even close to being able to see through the eye. And nanotechnology is technology that works within that atomic range and that level to fix or alter things within the atomic level. This has had many applications, as I said before, in medicine, material engineering, electronics, and much, much more. We're hoping that when in the future we will be able to get to the lengths and bounds that fantasy and pop culture has shown to it. But for now, this is what we have. Moving on to our next presenter.
Hello, my name is Imani-Hans and nanotechnology is relevant to my major as a computer engineer because it can be used for making way more smaller semiconductors and computer chips and multiple computer parts that when can be used way more smaller so we have way more efficient machines. And I'll be presenting what is nanotechnology and its background and history. So to answer the question of what nanotechnology really is we would first have to answer what is the science of these nano materials. And nanoscience is just the study of materials at a very, very small scale, at a scale of 1 to 100 nanometers. And just to put that in comparison, one strand of someone's hair is about 60,000 nanometers. So these materials are so small that we can't even see them with our eyes. And when these materials get so small, they start working way differently. They stop obeying the laws of physics that we usually see and start using and start working on the laws of quantum mechanics. And now for the background of nanoscience, we can look back to the 5th century BC and start seeing that the Greeks were talking about nanoscience and nanotechnology in the sense of thinking of what could they do if they shrunk or they started looking at a bar of gold and just start zooming in, and how small could they get like the materials to be. And that's what we now call atoms. But the first person to actually bring up the idea that we could use nanotechnology and nanoscience was a Nobel Prize winner, Richard Feynman, who basically said that if he stacked 24 volumes of the Encyclopedia Britannica, could they fit on the head of a pin? And this sparked so much intrigue for the science world, and so many scientists started running at the idea of trying to find nanomaterials and nanosciences, and if this could even be a possibility in the future. And this sparked the discussion of nanotechnology as a whole. Thank you very much, and I'll move on to the next speaker.
Hi, my name is Catherine Valdez, and today I'll be presenting to you about nanotechnology today in the modern world. And before I get into it, I'd like to connect how nanotechnology connects to my major and career. So I majored in biomedical science, so nanotechnology in the biomedical field has a huge impact on me now and in my future career. And that there's a high possibility I may be working with nanotechnology in a variety of fields. So going to the presentation, nanotechnology today, after years of research practice, it's being used and implemented into a variety of fields including medicine, machinery, materials, sports, and clothing. Nanotechnology is notably being used in the field of biomedical science, which includes imaging, diagnosis, cancer treatment, and drug delivery. So, in imaging, in vivo imaging involves nanoparticles serving as biological markers which detect changes at the cellular level in human tissue. And nanoparticles show these changes through imaging scans, which help medical experts diagnose and identify what is going on at the tissue level in the human body. Nanotechnology is also being used in cancer treatment, in which they may be formed as a use of immunotherapy along with radiation and chemotherapy. And they use the human body's own immune system to target and fight cancer cells. Nanotechnology is also being used in drug delivery, in that due to the nanoparticles' small size, they can easily pass through blood vessels in the human body and avoid clearance by phagocytes, which are cells in the human body that target other drugs and prevent them from easily entering the bloodstream. But because of their small size, they can easily avoid these phagocytes and remain in the bloodstream for longer periods of time in the human body, allowing them to have a longer and more prominent effect in their treatment.
Hello, my name is Nicolás Marcel Giliberti Taroco, and today I'm continuing the presentation on nanotechnology's breakthrough in the biomedical field. To begin, I'm a mechanical engineer major, and I actually have a minor in bioengineering, so nanotechnology is a very important subject to me because of the future possibilities which it can have on my career. We have endless possibilities, such as creating the first Iron Man, making superhumans, making the human body basically invincible. But yeah, continuing with the slides. To begin, the first research topics, which I'm going to be talking about, is how nanotechnology has helped advance research within the medical field to improve the human body. When I speak about improving the human body, I mean like bioengineers creating products such as fake artificial lungs and ways to implement medicine into the body, which would be more invasive, non-invasive, and help the human body continue. And more research topics such as facilitating human process and improving on known medical techniques. So instead of giving vaccines through needles, we can give them through little nanochips, or recently there's been Band-Aids with nanotechnology on them that produce vaccines through the body. Nanotechnology has also great promises in manipulating things at the atomic level. So this could be helpful to cure diseases such as cancer soon in the future. There's endless amounts of possibilities which we can have within nanotechnology, but yeah, there's millions of things: diagnosing, monitoring diseases, and we can have regenerative medicine, developing more vaccines such as the Band-Aid I was talking about, and different types of ways to deliver the medication. Continuing on, some STEM careers related to the topics such as biomedical engineering, sporting goods, and pharmaceuticals. In biomedical engineering, we have the creation of new biomedical sensors and non-invasive forms of medicine, such as the artificial lung, which I was speaking about, which is fake lungs, which help the human body breathe, it helps insert blood and has blood flow coming out and air coming in and gas coming out. This helps the lung produce more air and allows for the human to continue breathing. In sporting goods, we have new forms of clothing which are tight and more flexible when wearing. So this helps many like athletes while they're working out or something be more athletic, sweat less, And there's also technology which they've implemented into their wrists, like sort of like an Apple Watch, but it has like injectors into your wrist, and it helps monitor the human body and help people learn and how to improve on them. And in the pharmaceutical companies, they have been able to provide better structural and functional properties towards the medicine, such as having nanotechnology designs have new delivery systems and control particle size, surface properties, and drug delivery, and API release, so as to ensure site-targeted drug activity at an appropriate therapeutic rate. And moving on to the next.
To conclude our presentation on nanotechnology, I'm going to discuss the drawbacks as well as future implications and why I feel that nanotechnology is going to be used in the future. So nanotechnology has many incredible implications in many fields of STEM. Current applications as well as possible applications of nanotechnology would result in leaps of our current products as well as processes. While all these current and possible uses are exciting, nanotechnology is still a new field and comes with its own risks. With it being so small, it can create environmental concerns as well as even result in pollution. The size is also a concern because it is something so small that if something were to go wrong with it, that we wouldn't be able to tell too easily, and it would be really difficult to find it as well. The largest concern is that it's simply just too recent. While nanotechnology has been in the works for 40 years now, that's still fairly recent for most technology used today. And I feel that once it gets researched more, it could be more confidently applied to everyday life and fields of STEM and beyond. Despite these concerns and issues with nanotechnology, it has so much positive potential that it will definitely create waves within the fields of STEM. I feel as a mechanical engineering major that it also has a lot of uses, not just in medicine, where a lot of them do come up, but as well as mechanical engineering. In the image provided here, you can see super small circuitry, and that is it being used in electrical engineering, but it also has applications in mechanical engineering because micro-sized tools, which can be used to work on super small things, count as nanotechnology, and that can really help in certain parts of mechanical engineering. These are the references and sources we used. Thank you so much for listening to our presentation.